We'll start in 1 minute. We'll start on the test 4 review sheet today, and we'll work on it tomorrow also. And then on Friday, we'll have test 4 starting a few minutes before 8 o'clock. Okay, from section 9.1, we use the square root property to solve quadratic equations. So for this one, 3 times the binomial x plus 5 squared equals 72. First, divide both sides by 3, and we get x plus 5 squared equals 24. And then apply the square root property. And when we apply the square root property, we get x plus 5 equals positive and negative square root of 24. Then we can subtract 5 from both sides and write it as x equals negative 5 plus and minus. We can simplify the square root of 24. So the largest factor of 24 that's a perfect square is 4. So we'll write this as the square root of 4 times 6. And then finally, we can write x equals negative 5 plus and minus 2 times the square root of 6. So those are the 2 solutions. In the next example, we have the binomial 5y minus 7 squared equals 23. So this is all ready for us to apply the square root property. So when we apply the square root property, we get 5y minus 7 equals positive and negative square root of 23. I don't really need the parentheses. In the next step, we can add 7 to both sides. So we get 5y equals 7 plus and minus the square root of 23. And the square root of 23 cannot be simplified, so we just write y equals 7 plus and minus the square root of 23, all divided by 5. So those are the 2 solutions. In section 9.2, we learned how to solve quadratic equations by the completing the square method. So when we apply this completing the square method, we want the x squared term and the x term by itself on one side. And then if necessary, we divide every term on both sides by the coefficient of the x squared term. Then we complete the square. So the first step, let's subtract 8 from both sides. So we get negative 4x squared minus 24x equals negative 28. Before completing the square, in other words, before creating a perfect square trinomial, we need to divide every term on both sides of this equation by negative 4. When we divide every term on both sides by negative 4, we get x squared plus 6x equals positive 7. In the next step, we're going to add a number to both sides of the equation. And the number that we add will create a perfect square trinomial on the left-hand side. So now that the coefficient of x squared is 1, to complete the square, or to create a perfect square trinomial, we take 1/2 of 6 and square it. So 1/2 times 6 is 3. And then when we square 3, we get 9. So we're going to add 9 to both sides. X squared plus 6x plus 9 equals 7 plus 9. And then x squared plus 6x plus 9 is the binomial x plus 3 squared. And on the right-hand side, 7 plus 9 is equal to 16. And then we complete we apply the square root property. The goal is to solve for x. So since x plus 3 quantity squared equals 16, apply the square root property, we get x plus 3 equals positive and negative square root of 16. And then in the next step, we can do two things. We can subtract 3 from both sides. So we get x equals negative 3 plus and minus 4, because the square root of 16 is 4. And we can simplify further because all of the numbers are integers. One solution is x equals negative 3 minus 4, which is negative 7. The other solution is x equals negative 3 plus 4, which is positive 1. Okay, that's good enough, but I'll just make it more clear. The two solutions are x equals negative 7 and x equals positive 1. All right, and just another comment, if you have a problem like this on the test, if the directions say solve the quadratic equation by completing the square, then you'll need to show a few steps, and make sure that you don't try to do all of the work in a single step. So put a few steps in there so that the process can be observed. Okay, the next one, the same directions. Solve this quadratic equation by completing the square. 3y to the second minus 30y plus 26 equals negative 28. The first thing to do, subtract 28 from both sides. So we get 3y to the second minus 30y equals negative 54. Negative 28 minus 26 is negative 54. Then we divide every term on both sides by the coefficient of y squared. So since the coefficient of y squared is 3, we divide every term on both sides by 3, and we get y squared minus 10y equals negative 18. Now we are ready to create a perfect square trinomial. We're going to add a number to both sides of the equation, and the number that we add will make the left-hand side a perfect square trinomial. So now that the coefficient of y squared is 1, we take half of negative 10 and square it. So half of negative 10 is negative 5. When you square negative 5, you get 25. So we're going to add 25 to both sides of the equation. The left-hand side is now a perfect square trinomial, y squared minus 10y plus 25. In factored form is y minus 5 to the second power, and the right-hand side is positive 7. And then we apply the square root property. If y minus 5 quantity squared is 7, then y minus 5 is equal to positive and negative square root of 7. The square root of 7 cannot be simplified, so in the next step, the solutions are y equals 5 plus and minus the square root of 7. Okay, in the next section, next page, these problems from section 9.3 solve the quadratic equations by using the quadratic formula. So make sure that you know the quadratic formula exactly the way that it should be stated. So I'll just up here, I'll write what those are. The solutions to ax squared plus bx plus c equals 0, or x equals negative b plus and minus the square root of b to the second minus 4 times a times c, all divided by 2 times a. For this quadratic equation, it's already in standard form. A is 3, b is 2, c is negative 5. So make sure you write x equals and then apply the right-hand side of the quadratic formula. So in this case, x equals negative 2 plus and minus the square root of 2 to the second minus 4 times 3 times negative 5, all divided by 2 times 3. And so x equals negative 2 plus and minus the square root of 4 minus 4 times 3 times negative 5. 4 times 3 is 12. 12 times negative 5 is negative 60. So inside the square root, it's 4 minus negative 60. And all divided by 6. And just a couple more steps. X equals negative 2 plus and minus the square root of positive 64, all divided by 6. And the square root of 64 is going to simplify to 8. So we have x equals negative 2 plus and minus 8, all divided by 6. Well, we can simplify further, and we're going to need to write the solutions separately. So one solution is negative 2 minus 8 divided by 6, or negative 10 divided by 6. And that can be written in lower terms, which is negative 5/3. And the other solution, x equals negative 2 plus 8 divided by 6, which is positive 6 divided by 6, or positive 1. Okay, so the two solutions are negative 5/3 and positive 1. In the next quadratic equation, 4y to the second minus 12y plus 7 equals 0. It's in standard form. A is 4, b is negative 12, c is positive 7. So we write y equals the negative of negative 12, that's the negative b part, plus and minus the square root of the number negative 12 squared minus 4 times 4 times 7. And this is all divided by 2 times 4. And then we do the arithmetic. Y equals the negative of negative 12 is 12, plus and minus the square root of the number negative 12 squared is 144. And from it, we are subtracting 4 times 4 times 7. 16 times 7 is 102. Sorry, 16 times 7. Sorry, that's 112. And then all divided by 8. So a couple more steps. Y equals 12 plus and minus the square root of 32, all divided by 8. The square root of 32 can be simplified. 16 times 2. So the square root of 32 simplifies to 4 times the square root of 2, all divided by 8. And every term in the numerator and the denominator have a common factor of 4. So if we divide everything by 4, we're going to get 3 plus and minus the square root of 2, all divided by 2. Okay, in the next example, 2x squared minus 6x plus 28 equals 0. We could just start out by using the quadratic formula, using a equals 2, b equals negative 6, and c equals 28. But since we're solving an ordinary quadratic equation, and each of the terms has a common factor of 2, we can get rid of some of the clutter that's in the way if we divide every term on both sides of the equation by 2. So I'm going to do that. You don't have to do that if you don't want to. But when we divide every term on both sides by 2, we get x squared minus 3x plus 14 equals 0. The solutions to the two equations are exactly the same. But let's solve this one with a equals 1, b equals negative 3, and c equals positive 14. Okay, so x equals the negative of negative 3 plus and minus the square root of the number negative 3 squared minus 4 times 1 times 14, all divided by 2 times 1. And then the arithmetic, x equals positive 3 plus and minus the square root of 9 minus 56, all divided by 2. The discriminant is negative, so x equals 3 plus and minus the square root of negative 47, all divided by 2. And then the square root of negative 47, we're going to write that as the square root of 47 times I. And the square root of 47 can't be simplified any further. So our two solutions are non-real numbers. 3 plus and minus the square root of 47 times I, all divided by 2. So we're just using the definition for the imaginary unit. I is equal to the square root of negative 1. called the imaginary unit. It's just a definition. My suspicion is that it's used for convenience because it's easier to write the lowercase letter I than it is to write the square root of -1. Okay, let's move on to the next page. Section 9.5, we have some word problems. This is a work problem, so equations have the form rate times time equals 1. Working alone, it takes Joseph 5 minutes less to load a semi-trailer with hay than Fred, but if they work together, they can load a trailer in 6 minutes. Find the amount of time it takes each to load a semi-trailer alone. Okay, so for Joe and Fred, Joseph takes 5 minutes less than Fred when working alone. So if we assign Joe's time to be X minutes, then Fred's time is 5 minutes more because Joe is 5 minutes less than Fred. So we can write Fred's time as X plus 5 minutes. So for Joe, we can write an equation, rate times time equals 1. So Joe's rate times X minutes equals 1. For Fred, Fred's rate times X plus 5 minutes equals 1. And then when they work together, they can load the trailer in 6 minutes. So when they work together, Joe's rate plus Fred's rate times 6 equals 1. The goal is to solve for X so that we know what Joe's time is and Fred's time is. So we need an equation whose only variable is X. So if we solve for Joe's rate is 1 over X. Fred's rate is 1 over X plus 5. And the sum of the rates, Joe's rate plus Fred's rate, is 1 over 6. In the next step, we replace Joe's rate in this equation with 1 over X. So 1 over X, and then plus Fred's rate, which is 1 over X plus 5. They add up to 1 over 6. We have an equation with rational expressions. The only variable is X. So the common technique is to find the least common denominator, which is 6 times X plus 5. And then multiply every term on both sides by the least common denominator. When we multiply 6x times X plus 5 times 1 over X, the X's cancel, and we'll be left with 6 times X plus 5. When we multiply the least common denominator by 1 over X plus 5, the X plus 5 factors cancel, so we're just left with plus 6x. And then on the right-hand side, multiply 1/6 times the least common denominator. The 6's cancel, so we're just left with X times X plus 5. This equation is a quadratic equation, so we'll multiply everything out. 6 times X plus 5 is 6x plus 30 plus 6x equals x to the second plus 5x, or 12x plus 30 equals x squared plus 5x. We'll make the left-hand side 0 by subtracting 12x and subtracting 30, and we get the equation 0 equals x squared minus 7x minus 30. And we can use the quadratic formula to solve this, but this factors really nicely. One factor is x minus 10, and the other one is x plus 3. The two solutions to the equation are positive 10 and negative 3. But for this problem, the solution that we want is the positive solution. So x is 10 minutes. That means Joe's time. It takes Joe 10 minutes to load the trailer by himself. And Fred takes 10 plus 5, or 15 minutes, to load the trailer by himself. Okay, in the next problem, we have a right triangle. It says the long leg of a right triangle is 7 feet longer than the short leg, and the hypotenuse is 8 feet longer than the short leg. So let's draw a right triangle to help us. Notice that the long leg is described in terms of the short leg, and so is the hypotenuse. It's described in terms of the short leg. So if I label the short leg with x feet for the short leg, x feet, the long leg is 7 feet longer than the short leg. So the long leg is represented by x plus 7, x plus 7 feet, and the hypotenuse is 8 feet longer than the short leg, so x plus 8 for the hypotenuse. Then we apply the Pythagorean theorem to that right triangle. So we square the hypotenuse, square the length of the hypotenuse, x plus 8 squared, and that's equal to the sum of the squares of the lengths of the two legs. So that's equal to x plus 7 quantity squared plus x squared. We get a quadratic equation, so we're going to multiply everything out, combine like terms, set one side equal to 0, and then solve the quadratic equation. X plus 8 squared is x plus 8 times x plus 8, which is x squared plus 16x plus 64. On the right-hand side, x plus 7 quantity squared is x squared plus 14x plus 49, and then plus x squared. So let's make the left-hand side 0 by subtracting x squared from both sides, subtracting 16x from both sides, and subtracting 64 from both sides. So the left-hand side will be 0. The right-hand side begins with 2x squared, and when we subtract 1x squared from both sides, we'll just have 1x squared left on the right-hand side. And then 14x minus 16x is minus 2x. And finally, 49 minus 64 is minus 15. So this quadratic equation is in standard form. We can always use the quadratic formula. We can also always solve by completing the square. But if you can see a way to factor it, that's probably the more efficient thing to do. And this factors really nicely. One factor is x minus 5, and the other one is x plus 3. This equation has two solutions. One is positive 5, the other one is negative 3. So since lengths of triangles are measured with positive quantities, we want the positive solution. So the length of the short leg is 5 feet. The length of the long leg is 5 plus 7, or 12 feet. And then the hypotenuse, 5 plus 8, is 13 feet. Okay, on the next page, a couple more word problems. In a river, Charles rowed a boat 2 miles against the current and 4 miles with the current in 4 hours. So a total of 4 hours was needed to row 2 miles against the current and then 4 miles with the current. In still water, Charles can row a boat at 6 miles per hour. Find the speed of the current. Okay, so we'll pick a variable for the current speed, or the speed of the current. I'll just pick x, miles per hour. And then against the current, we'll have an equation of the form rate times time equals distance. So against the current, the boat will be traveling 6 minus x miles per hour. I'll use t sub a to represent the amount of time the boat was rowing against the current. And we're told that the distance against the current is 2 miles. So we have the rate of the boat multiplied by time equals distance. And then the boat was rowed with the current. So if the boat is going with the current, it's traveling at 6 plus x miles per hour multiplied by t sub w. That represents the amount of time it took to row 4 miles with the current. And we're also given information about the two times. The total amount of time that it took to row 2 miles against the current plus the amount of time it took to row 4 miles with the current is 4 hours. Okay, so we want to know what x is. We want an equation whose only variable is x. So we're going to use these three equations to get an equation whose only variable is x. So solve these two equations for time. So t sub a, the time that it took to row 2 miles against the current, is equal to distance divided by rate, 2 divided by 6 minus x. T sub w, that was the amount of time it took to row 4 miles with the current. That's equal to distance divided by rate, 4 divided by 6 plus x. And then in this equation, we replace t sub a with 2 over 6 minus x, replace t sub w with 4 over 6 plus x, and set them equal to 4. So our equation is 2 over 6 minus x plus 4 over 6 plus x equals 4. Here is our equation whose only variable is x. So the standard approach find the least common denominator, multiply every term on both sides by the least common denominator, and then solve the resulting equation. So the least common denominator is the binomial 6 minus x times the binomial 6 plus x. And when you multiply those out, it's just going to become 36 minus x squared. Okay, we multiply every term on both sides of this equation by the least common denominator. When we multiply 2 over 6 minus x by the least common denominator, the 6 minus x factors cancel, and we'll be left with 2 times 6 plus x. And then we multiply 4 over 6 plus x times the least common denominator. This time the 6 plus x factors cancel, so we get plus 4 times 6 minus x. And then on the right-hand side, we multiply 4 times the least common denominator. This time I'll write the least common denominator as 36 minus x squared. We don't get any cancellations this time. The resulting equation is a quadratic equation, so we'll multiply everything out. 2 times 6 plus x is 12 plus 2x. And then 4 times 6 minus x is plus 24 minus 4x. On the right-hand side, 4 times 36 is 144, and then minus 4x squared. So let's combine like terms on the left-hand side. 12 plus 24 is 36, plus 2x minus 4x is minus 2x, and that's equal to 144 minus 4x squared. So in the next step, I'll add 4x squared to both sides and subtract 144 from both sides. So we'll get 4x squared and minus 2x, and then minus 112 equals 0. To get rid of some of the clutter, we can divide every term on both sides by 2. And then we have this equation, 2x squared minus x minus 56 equals 0. And then use the quadratic formula, where a is 2, b is -1, and c is -56. So squeeze what I can here in here, so we get x equals the negative of -1 plus and minus the square root of -1 squared minus 4 times 2 times -56, all divided by 2 times 2. So on another piece of paper, I'll write down what we have. We have x equals +1, because the negative of -1 is +1, plus and minus the square root of +1, and then minus 4 times 2 times -56. So that's minus negative 448. So that's the same as plus 448. All divided by 4. Notice that the solution that we get by subtracting is negative. We want the positive solution because x is the speed of the current. So we'll write x equals 1 plus the square root of 449, all divided by 4. Okay, that's as far as I'm going to take that one. Okay, let's look at the next problem, part D. An arrow is shot upward at a rate of 220 feet per second. Use the projectile formula. The projectile formula should be h equals negative 16t to the second. And then v sub 0 represents the initial velocity, which is given to be 220 feet per second. So we'll write that as plus 220t. And then it says, determine when the height of the arrow will be 400 feet. So what we do, since h represents the height, we just replace h with 400 and then solve the quadratic equation for t. So I'm going to add 16t to the second to both sides and subtract 220t from both sides. And after doing that, we'll get 16t to the second minus 220t plus 400 equals 0. And then the solutions to this equation are solutions for t. T represents time, so that will be the amount of time it takes for the arrow to reach or to be at 400 feet. Okay, we can whittle this down a little bit. Let's start by dividing every term on both sides by 4. And then we might be able to reduce it even further. But let's start with that. We can see that 4 goes into all those numbers. Divide every term on both sides by 4, we get 4t to the second. And then minus 55t. Yeah, I think that's right. And then plus 100 equals 0. Okay, that's probably the best we can do as far as reducing the amount of clutter that's in the way. So if we use the quadratic formula, a is 4, b is negative 55, and c is 100. So t equals the negative of negative 55 plus and minus the square root of the number negative 55 squared minus 4 times 4 times 100, all divided by 2 times 4. So t equals positive 55 plus and minus the number negative 55 squared. That's 3,025. And then subtract 1,600. And then divide it all by 8. So I'll just take this one step further and point out a couple of things. So t equals 55 plus and minus the square root of 1425, all divided by 8. So notice that both solutions are real numbers. The smaller solution, so the t equals 55 minus the square root of 1425, divided by 8. This will be the first time that the arrow reaches 400 feet. That's on the way up when it's shot upward. Right, the arrow has sort of a parabolic trajectory. So on the way up, it reaches 400 feet in this many seconds. But then when it comes back down, it's going to be at 400 feet a second time. And that's the other value of t, 55 plus the square root of 1425 over 8. Okay, let's start the next page. This is where we graph quadratic functions. Find the intercepts, vertexes, and the equations for lines of symmetry. Okay, the y-intercept, when x is 0, the y-coordinate is 6. The x-coordinate of the vertex is, the formula for that is negative b over 2a. So in this one, b is negative 8 and a is 2. So the negative of negative 8 divided by 2 times 2, or 8 divided by 4, is positive 2. So the vertex has an x-coordinate of 2. To find the y-coordinate, you just replace x with 2. So 2 times 2 squared is 8. 2 squared is 4. 2 times 4 is 8. And then minus 16 is negative 8. Negative 8 plus 6 is negative 2. So the vertex is the ordered pair 2, negative 2. The line of symmetry is x equals 2. This is the same x value that is the x-coordinate of the vertex. That's the line of symmetry. To find the x-intercepts, we replace y with 0 and solve for x. So 0 equals 2x squared minus 8x plus 6. We can divide every term on both sides by 2 to get a simpler process. So divide every term on both sides by 2, we get 0 equals x squared minus 4x plus 3. And this equation can be solved by factoring. X squared minus 4x plus 3 is x minus 1 and x minus 3. So the x-intercepts are the ordered pairs 1, 0, and 3, 0. So we can sketch this parabola. So negative, or 2, negative 2 is the vertex. One x-intercept is 1, 0. The other x-intercept is 3, 0. So that is the rough sketch of the parabola. We know that it opens upward because the leading coefficient is positive. Okay, we have less than a minute left, so tomorrow we'll continue with the test for review sheet. I might skip a couple of problems here and there just so that we can see examples of each of the problem types on the rest of the review sheet. But that's all for today, so go ahead and sign in for attendance. Have a good one.